G'day guys, we've got a question here which is from a mid-year calculus exam. The question says that the height in meters of a lift above the ground t seconds after it starts moving is given by this particular function here. The question says that we have to use the increments formula to estimate the change in height of the lift from t equals 5 pi on 6 to t equals 17 pi on 20. So basically this is the generalized version of our increments formula where we have for small changes in the independent variable, the derivative can be approximated by the actual derivative at a particular point. So what we have to do here, guys, to start with, is let's just change this into the terms that we're going to be using in the problem. So what we've got here is we've got h in terms of t. So what we're after is we're looking for the change in height. So we're going to be looking for delta h, and that can be approximated by the derivative, or dh, with respect to t, evaluated when t is equal to 5 pi on 6 multiplied by the incremental change in the time. So to start with, guys, if you don't know what to do, the first thing you can do to give yourself some marks is figure out what this delta t is going to be. So what we're going to do is let's just work that out. We've got delta t is equal to the final time, which is 17 pi on 20, minus 5 pi on 6. Now this is going to be equal to, both are going to be over 60 is our factor, that's the factor that I'm going to use. And we have to times this by 3, so that's going to be 17 times 3 is 51, minus 6 is going to be times 10, so it's going to be 50 pi on 60. So that, guys, is just equal to pi on 60. Now, although that seems pretty basic, for the 6 marks that this question is worth, you might get 1 for just writing this. And you might even get 1 for explaining what the incremental formula is. So after we've worked out our delta t, what we're going to do next is we've got to work out our derivative of height with respect to time. Now, the way I'm going to do this to differentiate this height function here, I'm going to use the chain rule, which can be written as the derivative of height with respect to time is equal to the derivative of height with respect to some arbitrary variable which we substitute in, multiplied by the derivative of that arbitrary variable with respect to our original independent variable dt. Cool. So what I'm going to do here, guys, is I'm going to define u as cos of t over 5. And so as a result, what that means is my height in terms of u is going to be equal to 2 times u squared. Cool. So first of all, what we're going to do is I'm going to take the derivative of both of these functions. So dh du is quite a simple one. It's just going to be 4 times u. And du dt is going to be equal to the derivative of cosine is negative sine of t on 5 multiplied by the derivative of this inside part, which is a fifth. So obviously this can be rewritten as negative sine of t on 5 all divided by 5. Cool. Okay, so from here, guys, we can basically write out the full derivative as being the product of these two subsequent parts that we've just found. So we can say that dh dt is going to be equal to dh du, which is 4u, multiplied by du dt, which is negative sine of t on 5 on 5. Now what I'm going to do, guys, I'm going to replace my u with cosine of t on 5. So I'm going to put cosine of t on 5 into here. And I get 4 cos t on 5 times negative sine of t on 5. And we can sort of make this look a little bit tidier by saying this is equal to negative 4 over 5 sine of t on 5 times the cosine of t on 5. Cool. So now we have our simplified version of the derivative of height with respect to time. we're going to sub it into our increments formula. So we're going to be able to say, if I rewrite our increments formula down here, that the incremental change in height can be approximated by the derivative of height with respect to time, evaluated at our original time, multiplied by our incremental change in time, which is equal to our derivative here, negative 4 over 5 sine of t over 5 cos of t over 5, multiplied by our incremental change in time, which we worked out right at the start to be equal to pi over 60. Now what we're going to do is we're going to evaluate sine of t over 5 cosine of t over 5 at time equals 5 pi on 6. So for both of these, if we just do a little bit of working out on the side, 5 pi on 6 multiplied by a fifth is going to be equal to simply pi on 6. So this is going to be equal to negative 4 over 5 sine of pi over 6, which is equal to a half, times the cosine of pi over 6, which is root 3 over 2, finally times that incremental change in time, which is equal to, we've got 2 times 2 is 4, which will cancel out the 4 at the top. We'll be left with a 1. And we have a root 3, a 5 times 60 is 300. So we're going to be left with square root, or well, negative square root 3 pi on 5 times 60 is 300. And what we do is we quickly scan back to the top. And we find that the height is in meters. So we can say at the end that therefore the incremental change in height will be approximately root 3 pi over 300 meters downwards because of the negative sign out the front. Or we could say height decreases by square root 3 pi over 300 meters. Cool. So let's just go through what we did here, guys. What we did for our first step is we rewrote our incremental formula or formula of increments in the variables or in the units which the question is in terms of height and time. So we were able to give ourselves almost like an action plan to solve the problem. From here, what we did is the real first bit of maths that we did was we calculated this delta t here, which was calculated simply by subtracting the final time from the original time. Not very complicated maths, but it's important to do so we can get an answer. It's also important to do, if, like we said before, if you don't know where to go to start with, this is a good place to start so you can get some marks on the board. What I then did is, because of the particular function that we were given for height in terms of time, we needed to use the chain rules to differentiate it by hand. So what I then did is I wrote down for myself the chain rule, which is here. So I again give myself a roadmap of what I need to do to solve it. I then figured out that to work out dh du, I needed to substitute u for cosine of t over 5. I then did my differentiation. So this is the second step, is do the differential. And the third step is then putting the pieces of the puzzle together. So this is the third step here. So what I did is I rewrote my formula of increments. So this was then rewritten down here. And then I substituted all of the information that I'd gathered throughout the question into this formula of increments. I have my derivative of height with respect to time, plus my incremental change in time. I then evaluated all of the components at the initial time, which was 5 pi over 6. And then I came out with my answer of negative root 3 pi on 300. I then went back up to the question and worked out that this was in meters. And so you have to make sure that we include the units which we are changing by. Otherwise, we're not going to get full marks for the problem. So guys, again, I hope this question helped. If it did, give it a thumbs up and subscribe to my YouTube channel. If you have any problems with the way that I've solved it, please leave it in the comments section below. I'd be happy to answer any of the questions you have on this particular problem. Alternatively, if you have any other problems which concern calculus and incremental change, please also leave them in the comments section below, and I'm always looking for new video ideas and be happy to help wherever I can. So until next time guys, these type of problems in exams can be quite challenging just because of the pressure of exams, but the only way that you're going to be able to bridge that gap is by practice. You must keep bashing your head against the wall. Eventually the wall will fall down. So keep practicing, 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 but guys, most of all, please just keep enjoying your maths. So until next time, I'll see you soon.